All right, this is a continuation of our Chapter 2 quiz review notes, and we are on example number 4, which is going to be like your homework problem number 4. So we want to find the volume of the solid obtained by rotating the region bounded by y equals 7x squared, x equals 1, and y equals 0. So and we're revolving this around the x-axis. So let's move this over so we have room to write. Hold on. Okay, and y equals 0. All right, so we want to take these equations now. For your quiz, this is when we're going to start revolving things around the axis. So we have the equation y equals 7x squared, which is a parabola, pretty steep parabola. Y equals 7x squared, and then also x equals 1 and x equals 0. So we are going to be rotating this whole region around the x-axis. We do want to know where these are going to cross. That's going to be at the point 1, 7. I know that because I know that line is at x equals 1. I can plug 1 into this equation and I get 7. So that's where I know that those 2 points are going to cross. Is it 7? No. Those 2 points are going to cross at 1, 7. So 1, 7. And then we can reflect that down here and show that we are rotating that around. It's kind of hard to do, but there we go. So we are going to rotate that equation around the x-axis. So to do that, we need to find the volume of this equation. So the volume is going to be the integral of the area of one section. So let's pull out one section of this shape. If we pull that out, we are going to get a solid circle. So this is a solid object. It does not have any holes or gaps in the middle. So with this solid object, the area of that circle is going to be pi r squared, where the radius is the distance from the x-axis up to our equation. So we're going to integrate the area equation, which is pi times r squared, where r is always going to be the distance between the x-axis and the equation, and squared, and then dx. All right, our limits of integration, kind of already talked about. We're going to go from 0 to 1 on the x-axis. And let's make that look a little bit better. We've got pi we can pull out in front from 0 to 1. 7 squared is going to be 49. X squared is going to be x to the 4th. And then dx. And now we're ready to go ahead and integrate. So we'll have pi times 49 times 1 over 5 x to the 5th. And all of that is being evaluated from 0 to 1. And so putting all that together, we get our final answer of 49 over 5 times pi. And that is our answer. At example number 5, we have another rotating one. So we're going to have to take one region and look at the area of that. For this one, we have y equals x squared, y equals 0, and x equals 4. and we are rotating that about the y-axis. I've done this problem 3 different times in the past week, and every time I forgot to solve for x. So let's not forget that. Go ahead and graph our equations. Let's have a look at what we are doing. So we have y equals x squared, which is just a nice parabola. And then we also have the line x equals 4. So let's say that that's about here. So we're also going to copy that over here to the other side because we are rotating this around the x-axis, or y-axis. All right, and then it is all of this region that we are finding the volume of. So notice this one, when we rotate it around our y-axis, this one is actually going to have a hole in the middle. So for this one, we're going to want to use our washer method. And we have 2 radius, an inside radius and an outside radius that we need to worry about. Okay, so you guys get the idea. We're going to rotate that around that y-axis. So a couple of different things that we need to do. First thing that we need to do is we need to know what our limits of integration are. So we are going to integrate from 0 to this top number up here. Well, that's going to be where these 2 equations meet. But to be able to do that, we also need to know what our 2 equations are, because we are rotating around the y-axis. When we take out one section, when we take out this one section, the width of that section is going to be a dy, since we're on that y-axis. And when we look at that one section, we're going to have a big circle, a smaller circle inside. So the area for this, oh, thank you, JCPenney. We get A equals, or the area of this object here is going to be the area of the bigger circle minus the area of the smaller circle. So the area of our bigger circle is going to be equal to pi, I'm going to use a capital R for my big radius, pi r squared, and the area of the smaller circle is going to be pi little r squared. Right? And then our overall radius, we can factor that pi out, and we get pi times big R squared minus little r squared. All right, and then that's our equation that we want to integrate. All right, so going back over here, we were in the process of solving for x. So if we have y equals x squared, and then x is equal to the square root of y, and x is equal to 4. So setting these 2 equations equal to each other, we have 4 equals the square root of y. Square both sides to solve for y. We get y equals 16. So this equation we're going to be evaluating from 0 clear up to 16. Alright, I'm going to pause here for a second and clean off my board, so I hope I have all that written down. You can pause and rewind if you need to. Alright, so I got a little bit more room here. So now we have volume is equal to the integral of Sage pi times our big radius squared minus our little area squared, and then those are going to be in terms of dy. And let's go back up here and rewrite those equations. We have the equations x equals square root of y and x equals 4. All right, so if we're looking at this picture that we pulled out, the circle that we pulled out, which now looks like a washer, our bigger area is going to be the x equals 4. The smaller area is going to be the x equals the square root of y. So we're going to be integrating. Remember, we found from 0 to 16. I can pull this pi out in front. And then our big R is 4 squared minus our little r is the square root of y squared. Oops. Square root of y squared dy. So let's fix that up a little bit. Pi 0 to 6 of 16 minus y dy. And now we're ready to integrate. And we have pi times 16y minus 1/2 y squared, and then all of that evaluated from 0 to 6. Okay, so let's plug in 6 minus 6 squared is going to be 36 over 2. And then solving all of that, make sure I have the right answer here. Yep, we look good. We should have 128 pi.